doing class 7 physics, and we'll continue from what we have left last time. And last time we did heat and temperature, and then we discussed about temperature in the beginning, then we discussed about heat, and then we continued with the process, the effects of heat, and the process in which one state of matter changes into another, and we'll continue that. Okay, so last time we only talked about, we did discuss briefly about the entire process, but we focused mainly on melting. So what was melting and what is freezing, and specific latent heat or fusion of ice. So we'll continue from that, and we'll be doing vaporization. Okay, so today we'll be doing vaporization. What is vaporization? You know it very well, isn't it? When liquid changes, when liquid gains heat and converts into another state, that is your gaseous state. So the process in which in which the liquid changes from liquid to gases is called vaporization. And how does this vaporization take place? So what happens is, the liquid particles, when they absorb heat, okay, when the liquid particles, that is molecules, they absorb heat, they start moving faster. So I told you last time, when the particles, they gain heat, they start moving faster. That means their kinetic energy increases. And when their kinetic energy increases, the intermolecular space also increases. And the force of attraction between the two molecules, they start becoming weak. Okay, and thus the space becomes more. And when there's too much space, that means when the particle starts moving far apart from each other, the liquid particles changes to gaseous particle. And there will be no change in temperature till all the liquid converge into gases. Okay, so when you suppose if you're boiling water and you record the temperature, if it's 100 degree when it's boiling, and when it starts converting into gases, if you record the temperature, you will still find all the water which has been converted to gases will also be at the same temperature, that is 100 degrees Celsius. So there will be no rise in temperature. And I told you last time why, because for boiling it requires the latent heat. Okay, so this is how vaporization takes place. Now, just like specific latent heat or fusion of ice, we have specific latent heat or vaporization. Okay, vaporization of water, and how much heat, okay, or specifically how much heat do we require to boil 1 kg of water? Okay, how much heat do we require to boil 1 kg of water? To vapor is at 100 degrees Celsius is how much do we have here? 226,000, which means we have 22,60,000 joule of heat. So in order to convert 1 kg of water into vapor at 100 degrees Celsius, how much heat do you require? 22,60,000. So if we have to if you have to vaporize 2 kg of water, you need to double the same amount of heat. Okay, if you don't have that much of heat, the entire water will not vaporize. There will be vaporization, but the entire amount of water will not vaporize. So if in order to vaporize 1 kg of water completely into vapor, you need that much amount of heat. That is 22,60,000. Okay, not less than that. So that is, you have to be very specific about that heat. So in order to be specific, it is called specific latent heat of vaporization. Now there are two kinds of vaporization. One is boiling, the other is evaporation. Okay, you might have heard both the terms, boiling and evaporation. In both this boiling and evaporation, liquid changes to vapor. Okay, but there are certain differences. You cannot say when you boil water, when you supply heat, when you're boiling water in a gas bomb, you cannot say it's vaporized, it's evaporated. Okay, though it evaporates, but still we say it's boiling when the liquid boils. So the difference between boiling and evaporation. Now you can see the difference. Evaporation is a surface phenomenon. Okay, surface phenomenon means it only takes place at the surface. Okay, deep down, if the liquid in the deep down, it doesn't take, the liquid doesn't vaporize from inside, only at the surface. Whereas for boiling, liquid boils throughout. Okay, the particles start boiling throughout. Evaporation. Okay, before we discuss this, now you can see this is what I meant. Surface phenomenon, it takes place only at the surface. This is your evaporation. It takes place only at the surface. Whereas for boiling, it takes place throughout the liquid. You can see the bubbles coming from inside the liquid as well, isn't it? So this is your boiling. Boiling takes place throughout. Evaporation is only at the surface. Here you don't see any bubbles. Okay. Second difference between evaporation and boiling. Evaporation is a slow process. Boiling is a fast process. Okay. So if you want to boil water, if you want to drink hot water, and in a cup, in the same cup, okay, you pour the same amount of water, and in one cup you keep it outside, that is on the sun, okay, so that it gets heated. And the other cup of water, you put it on your stove. Which one will get heated faster? Obviously, which has been on the stove, isn't it? It gets heated faster, which means boiling is a fast process than evaporation. Okay. The second difference, the third difference is evaporation takes place at all temperature. It's taking place right now. It takes place in a very cold day also. It takes place in a very, very hot day, depending upon the temperature. We'll come to that later. But then, as of now, just understand that evaporation takes place at any time. It's taking place now. It takes place at 1 p.m. It takes place at 1 a.m. It takes place at any temperature. Whereas boiling requires a certain temperature. That is your boiling point. So different liquids have different boiling points. Okay. Water boils at 100 degrees Celsius. You know that. So there are other liquids which boil at different temperature. You cannot just expect all the liquids to boil at the same temperature. Okay, that's why boiling has a fixed temperature, that is called boiling point. So these are the differences between evaporation and boiling. Evaporation is a surface phenomenon. Boiling takes place throughout. Boiling is a fast process. Evaporation is a slow process. Evaporation takes place at all temperature. Boiling takes place at a certain temperature, that is called your boiling point. Now, how does evaporation take place? So, we'll be discussing about evaporation more in the next class. We'll just move on to next, that is your condensation, another process where one state of matter changes into another, and that is your condensation. You know very well what is condensation, isn't it? What is condensation? When it is just the opposite, reverse of vaporization. That means when the gases loses heat and converts into liquid. So the process in which gases changes into liquid without any fall of temperature or any change in temperature is called condensation. What happens during condensation? During condensation, what happens? The gases, particles, they start losing heat. Okay, when they lose heat, the particles, they start moving slower. And when they start moving slower, they come closer. Okay, their intermolecular space decreases, they come closer. And their force of attraction increases. And thus, the molecules which were far apart, they come closer and change into liquid particles. So this is how condensation takes place. Another process is sublimation. So sometimes solid does not change into liquid. It directly gets converted to gases. You know very well, isn't it? And that process in which solid directly changes to gases are called sublimation. So you know the best example of sublimation are naphthalene balls, which we commonly call kapur, isn't it? Which we use at home so that we don't have stinky clothes. So you put those naphthalene balls on your wardrobe, isn't it? Maybe inside your clothes or maybe somewhere deep down inside in the corner of the cupboard. And then what happens? You just forget about it, and after a month when you come back, when you see it, you see the size has decreased, isn't it? But then even if you check your clothes or your wardrobe, there will be no trace of water. That means that solid has not converted to liquid. However, what you can do is you can smell it. You can smell that naphthalene ball, isn't it? You can smell it in your clothes, you can smell it on your wardrobe. That means, what does it mean? It means that solid has converted to gases. And that process is called sublimation. Now, the reverse of sublimation is deposition. That means even gases, when they lose a lot of heat, they can convert to solid. Okay, when gases lose a lot of heat, they come very much closer. The particles come very much closer, and then the force of attraction comes very strong like solids, and the particles, they change into solid particles. Okay, so the deposition means when the process in which gases changes to solid directly. They don't go through the process of converting into liquid, liquid into solid. Gases directly changes to solid, and that process is called your deposition. Your example for deposition is your frost, dry ice. Okay, all these are examples of your deposition. In dry ice, those carbon dioxide has been converted, gas would be converted to ice. Okay, which means gases has been converted to solid. So that is your process called deposition. So in the next class we will further discuss about evaporation. Okay, the factors which evaporation depends upon, how evaporation causes cooling, all those different examples. So we'll just finish it off for today. We've learned about temperature, we've learned about heat and the effects of heat and the change of process from one state to another. In the next class we will be discussing about evaporation, how evaporation causes cooling and the factors in which evaporation depends upon. So thank you, and till then you please study, go thorough whatever is being taught, and if you have any doubt please do call. Thank you.